Okay, guys, so now we are starting Unit 2, Exam 2, which has a lot of what was on Exam 2, what was on Unit 2, Exam 1. So again, we're going to do electronegativity, so you should know this table. You're going to have to say on the test which bond is the most polar using these values. So for instance, a CH bond C is 2.5 and H is 2.1. So the difference in electronegativity is going to be 0.4. I am using a off-brand Apple Pencil, so bear with me, guys. So again, charge density is something you will see on this exam as well. We did it last exam. So charge density is the same thing as lattice energy. The larger the charge, the higher the charge density, the higher the lattice energy. There are some molecules with the same charge. For instance, lithium and sodium, and beryllium and magnesium. So lithium and sodium have the same charge, so you're going to group them together. Oh my lord. Y'all see this, right? Because it's like literally going, I don't know. Okay, so the one with the higher charge density is going to be the one that is the smallest. So lithium is smaller than sodium. So lithium will have a greater charge density than sodium. Same thing, beryllium and magnesium. Beryllium is smaller than magnesium. So beryllium will have a greater charge density. Oh, I think I know how to work it now. No, I don't know how to work it. Okay. Moving on. Oh my god. You're hearing that little growl? That's my dog. She wants me to throw her toy. Okay, so again, the higher the charge, the greater the lattice energy. So for instance, +1, +2. Oh my lord. +3. Someone teach me how to write on this. So the +3 charge will have the greatest lattice energy. And the +2 charge will have a high lattice energy as well. See, like, what? How do I get it to stay? I don't know. And then so opposite, the lower the charge, the smaller the lattice energy. So the larger the radius, the smaller the lattice energy. The smaller the radius, the larger the lattice energy. So you're going to rank by charge first, and those are the same charge, you'll rank by size. See? smallest, oh my God. Is larger. Okay. Oh my Lord. That's horrible. But y'all get the point. The smaller, you want the smaller one to have a higher charge density and higher lattice energy. And again, you're going to have to do an ionic compound. An ionic compound is between a metal and a non-metal. Oh, I think I got it. No, I don't got it. A metal and a non-metal. So you're going to write the metal first as its element's name. So for instance, let's do sodium. And then you're going to write the non-metal. Let's say chlorine. And then you're going to add I to the non-metal. So sodium chloride. So if we see a metal and a non-metal, you're going to give it, oh my Lord. You're going to give it a name. I am just going to use the back of the pencil because that seems to be working better. Okay. We're good to go, guys. Okay, so you have to be able to, on the test, tell me which one is an incorrect salt. So group 1 and group 7. Group 1 has a plus 1 charge. Group 7 has a -1 charge. So when we swap them, you should have no subscripts. Group 2 has a +2 charge. Group 6 has a -2. So when you swap them, one gets a 2, the other one gets a 2. Okay, but remember, same subscript, you're going to drop. So you should get something like, for instance, CaO. No subscripts because they're both 2, so the subscripts would drop. 3 and 5, that is +3 and -3. Again, they're going to swap. Same subscripts, you're going to drop them. Group 1 and 6, that's +1 and -2. Okay, so you're going to give a +1 and a 2 right there. So you should have a 2 and B. So you're going to need 2 of the cations to balance out the anion. That's what that subscript means. You need 2 of the cations to balance out the anion, which is the B. You need 2 sodiums to balance out the oxygen. Okay, and this is just basically the same thing. Just look at the charts and see if they wrote it correctly on the test. This question is going to be like, which of the following, which is incorrect? And just see which one is written incorrectly. Which formula is incorrect? Formal charge. Okay, so this was also on your test, the past test. So formal charge is going to be the number of atoms, your valence electron. So depending on what group you are in, it'll be different for every single. So this is based off a group number. You're going to get that number and minus it 2 for every unbonded electron pair. And so how I like to do it is by going like this. I just count the electrons around it. So CH4 is our example on this question. Make sure that all your octet rule is satisfied. There are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8 around carbon. So we have 8 electrons around carbon, so that should be good for the drawing. Now we are going to do the formal charge. Carbon is in the 4th group, so it'll be 4 valence electrons on carbon. So we're going to minus every bond it has. So it has 1, 2, 3, 4 bonds, which is going to equal a 0 formal charge. So carbon has no charge. This is for carbon. Now for hydrogen, hydrogen has 1 valence electron. Okay, and then so we're going to minus every bond to that hydrogen. So just looking at one hydrogen, it has 1 bond, so we're going to minus 1 bond, which equals 0. So hydrogen also has a formal charge of 0. If it had a lone pair, like that, on the carbon, you would minus each electron. So not only would you do 4 bonds, but you would minus 2 electrons. But it is not. Okay, that is how you do formal charge. Multiple central atoms. These are like the easiest to do, and they typically give you these examples on the test. I saw this one on someone's test today, so it should pop up on the next test and the midterm for Unit 2. So C2H6. So let's do the first one. C2H6, C2, and 6 H's. So put 3 around each carbon. Carbon's easy because you just know it just needs 4 bonds. So 1 here, 2, 3. Oh, only you can bond to the carbon once. 1, 2, 3. So a typical way that they ask this in the test is like for C2H6, how many bonds are between the carbon? Just 1, just a single bond. C2H4, easy. 2 H's around each one. Bond atoms. There's only 3 bonds on the carbon, so it only has 6 electrons, so we need 2 more. So go ahead and double bond. Now C2H2, 1 hydrogen for each carbon. Okay, so we only have 2 bonds on the carbon, so we're going to double bond. Now 3 bonds on the carbon. We need 2 more electrons, so 1 more bond. So now we have a triple bond right here on C2H2, a double bond on C2H4, and a single bond on C2H6. Okay. Octet rule exceptions. If you got this wrong in the test, I'm going to be very mad at y'all. So this is one of the easiest questions to get right on the test. So one of the octet rule exceptions is radicals. So that is to have a odd number of electrons. So anything that is going to equal an odd number. Let me pull out my periodic table real quick on my phone. Oh wait, let's see if there's one in this other notes. There is. Okay, so this is old notes, so don't. So look at the periodic table. Nitrogen is going to have 5 valence electrons. Okay, and oxygen is going to have 6. So if we add them up together, we have 11. So this is a radical. Okay, now let's go to the next one. Again, nitrogen has 5 electrons. Oxygen has 6 valence electrons. So we're going to multiply that by 2, which should give us 12. So 12 plus 5, that's still going to give us 17 electrons. So it is a radical. N2O. N, again, is 5. We're going to multiply it by 2 to get us 10 electrons. O is 6. 10 plus 6 is 16. So this is not a radical. Let me just put the word not. A-rad. Okay. O3. O3 is, the O is 6 times 3. That's going to be 18 electrons. Not a radical. Remember, we're just looking for odd numbers. CO2 with the -1 charge. So C is going to be 4. Oxygen is going to be 6. But we're going to have 2 of those. So that will make it 4. 6 times 2 is 12. Plus a negative charge. So plus 1 electron. So that'll put us at 17. So this is a radical. Okay, I'll let you do the rest on your own.